What did you do for your birthday? What did you do for your birthday? Why would you want to get your license?
What?
Why would you want to get your license?
I was gonna do it tomorrow, but
Wait,
there were so many people there, so.
where did you go?
It was nice and cold.
So,
That was fun.
Your mom, not mine.
huh?
She just too afraid to take test tests. You should have. Okay, guys, so this is actually our last section of the chapter before getting ready for a test. Now, I can't remember the.
Wait, really?
Yeah, this is a short chapter. So, I think I mentioned it yesterday, but maybe you didn't hear me. Is we're probably going to test on Monday. With it being a short chapter, we're probably going to just review for one day. Part of our review we'll actually do today. We're going to do like a chart and talk about all our exponent rules today. So a little bit of review today. So if you look, these notes aren't very long. So, we'll be testing on Monday. Yeah. Well, it's a little. Since it's shorter, though, the test is less sections. The test is going to be a little less on points. So I wouldn't call it a quiz, but it's.
You know what we're doing for our break?
What's that?
What are we going to do?
Oh, for a break? I don't know. It came up. I don't have anything in particular planned. We could do something non-math related.
I go Pictionary.
Pictionary?
Yeah.
We'll check. We'll see. Okay, so if you haven't done so already, if you guys can take a minute with the warm-up question here.
What did you do that
Coloring on desk. And for this second problem, I prefer you have the answer not as a decimal. So I don't want a decimal for that second answer. So I want you to think about it maybe as a fraction. So that helps a little bit.
I was going to say, wait, it would be a decimal?
It could be a decimal.
I did not know that, so I was wrong with what I thought.
If you maybe just put it in your calculator, it would give you a decimal. I prefer to not have a decimal before it. So we'll talk about these here.
What would be a pretty small decimal?
Very small number, like less than a penny. Okay. So in the warm-up here, our exponent rules. So something like this, I would multiply those coefficients together. So 5 times 2, we get 10. And then I have that x to the fourth and x to the negative third. Now you could move it to the bottom of the denominator, the bottom of the fraction, or you could just combine them the way they are. If we combine 4 and negative 3, we get what power? 1. So this is just x to the first, or just x. So I think some of you guys might have done this. And you can do that, it's just when you simplify, it's just going to be an x to the first anyhow. So you can go that like step further, and you don't have to do it that way, but I like just combining them if I'm able to. So it's kind of up to you guys. A lot of times in these problems, I don't have a specific way that I think is, there's a way that I probably would choose to do, but there's probably not one good way to get there. There's lots of different ways. It's whatever you guys notice and are able to use. So the second one is the one where if you put in your calculator, some of your calculators will just give you a decimal. I wanted you guys not to just get a decimal for it. So if you get a fraction, I'd prefer it that way. I don't know what other option you have other than decimal or fraction.
Oh, mine will give me a fraction.
It will it?
Yes,
Oh.
it only gives me fractions.
And you hate that sometimes?
I hate it.
Okay,
1 over a
so what happens with this negative 3 power? How do I make that not negative? What do I do? What is this telling me to do? Yeah.
Instead of being 10 to the negative third over 1, you flip it so it'd be 1 over 10 to the third.
Yeah, so what I wanted you guys to think about it is this way, is that if I want to make that exponent positive, I would move that to the bottom of the fraction. Now 10 to the third is a really big number, but 10 to the negative third power is actually a really small number. So yeah, did you get like 1 over 1,000? Yeah, because 10 to the third is 1,000. So 1 over 1,000 is actually like less than a penny. It's like a tenth of a penny. So it's a very small number, like it's not worth anything if it was money. But you, this number as a decimal is like 0.001, and we don't want it that way. I want you guys to think about it though as a really, so if you want it as a decimal, just to really quick mention that, it's a very small number. So what I want you guys to realize is when we have those negative exponents, it makes the number smaller. So that's kind of important to point out for today as we talk about scientific notation. And you've probably done scientific notation, probably in science class or in math before, and it's something that allows us to all have a standard notation to compare very large, very small numbers. So, and this happens a lot in science class because things in science a lot of times end up being really, really big or really, really small. Like the size of like a cell, a really tiny cell, or like the weight of a cell, or the weight of even something that's, you know, that we see all the time. Scientific notation is a great way to explain that, so we're not writing something with all these crazy little decimals as we go here. So, like I said, it's probably something you've seen before. We're going to do a little bit of math with the scientific notation, but more than anything, just kind of want to dip our toe in the water so that when you guys see this, you're not like freaked out and like, oh, yeah, you know, like struggling with scientific notation or something like that. So I don't want that to be a struggle. So scientific notation has a standard way to write things. So the way we do that is we're gonna have a number, and I'm gonna write A, just some number, times 10 to the n power. So they always use a 10, and the A and n can be various values, and we'll talk about them in a second here. Now that A value, I always explain that as it needs to be a 1-digit number, and that's kind of confusing. So when a 1-digit number is basically anything from 1 to 9.9, like the first digit. I always talk to my students about, to kind of think about the size of the number as like either like vending machine money, concession stand money, so that like if you walked up to the concession stand, you'd have money to spend if it was like a 1-digit number. If you have like $30 and you spend that at the concession stand, I hope you'd question what you were all buying there. So A needs to be in between 1 and 10. It needs to be smaller than 10 but bigger than 1. So kind of a little compound inequality there to explain that. Now the n tells me how many times to move my decimal place. So it's how many times I'm multiplying or maybe even dividing by 10. So this is going to be how many times we move the decimal. Why do you think they use the number 10 to multiply by? Yeah?
Because 10 is like the number that moves the decimal.
Yeah, 10 moves the decimal because we do our math in what we call base 10. So every decimal point is basically worth like 10, like that value of 10. And multiplying by 10 is a really easy thing to do. You know, like if I say anything that we have to multiply by 10, it's really easy to do. I just move the decimal place 1 over. Or even if I'm dividing by 10, I just move it 1 over the other way. So understanding that using the 10 is good for us because everything is based on tens in our math system. Now, when they talk about standard notation, this is when you write the number with all the zeros. This is the way you would use money, or like use money. You wouldn't talk about it in scientific notation typically. So this is like the normal way to write things. So like with all the zeros, with the decimal point, so like the normal way you'd write things, not scientifically. So when the book will ask you guys to use standard notation, that means put all the zeros in. So these are both written in scientific notation. They're asking us to write it the normal way. So they want us to switch it over to standard notation. So kind of just talking to you guys about this. This is telling us to multiply 10 5 times. So you're multiplying by 10 over and over again 5 times. So if I'm multiplying by 10 5 times, the number's going to get bigger 5 times. So a positive exponent makes the number get bigger. So we multiply repeatedly. So we're going to multiply by 10 n times. So, because that power is our n. So this time we're going to multiply by 10 5 times. Now, every once in a while a student be confused about this and they want to add that number of zeros. It doesn't necessarily move, add that number of zeros. It's how many times we're going to move the decimal place. And so that's going to make our number bigger. This is going to end up being a large number. So I'm at 6.49. If I multiply by 10, I'm at 64.9. If I multiply by 10 again, I'm at 649. I'm going to multiply by 10 2 more times. So that means I have to add a couple zeros in there. So the new decimal place is behind that last zero. So this ends up being 64,900. So it's how many times, oh whoops, did I not move it enough? I only moved it 4,
Yeah,
sorry.
I was going to say, that does not seem right.
Okay, sorry, 4, one more time. I can count, I swear. So 5 times, how about that? Sorry, thank you. So 649,000, I'm like, looked at my work, I'm like, I did that wrong. So 649,000, so yeah, that decimal place is a big deal. So if this was your bank account, or like you're buying a house, and I mean, numbers that large, if I go from 64,000, I could probably buy a car, or a fancy car, or 649,000, I buy a very fancy house. That's a big difference. That decimal, that extra decimal point is important. So yeah, I'm glad you guys spoke up and said something.
Yeah, our Tahoe is well down much.
Really? Oh my gosh, it's crazy. So now, what do you think a negative exponent's going to do then?
Make it smaller.
It's going to make it smaller. Because if you think about the warm-up question, when we had 10 to the negative 3 power, that was a really small number. So 10 to the negative 4 is an even smaller number. So it's really like we're dividing by 10 that number of times. So we're dividing by 10 repeatedly. So we're going to divide by 10 that number of times. So this is going to be a very small number. So this time we're going to move the decimal place smaller 4 times. Hopefully I can count. 1, 2, 3, 4. So there's my new decimal place. So this time I'm going to have to add in 3 zeros. So this is a really, really small number. And I always talk about it being like a penny. It's way less than a penny. Now, if you like to put another 0 like on the other side, I'll explain why the books typically do that. That way it's pretty obvious where it kind of hugs that decimal point. But that 0 is not necessary. It doesn't really mean anything. So if you don't put that in, it's not the end of the world. It's kind of like a placeholder. So now we're going to go the other way. Now we're going to take something that's a really large or a really small number and write it in scientific notation. So these are the first one's a really big number. What is that, 46 billion? 200 million? Yes, kind of a big number. So like crazy amounts of like size of something. It's hard to even understand how big that is. So we want this to be in scientific notation. So the first value has to remember be a 1-digit number. So think about, like I said, like lunch money or concession stand money. Right now, first of all, where's the decimal? The very end. So it's way back here. Where do I want the decimal to go? Yeah, we want it to be like $4.62 there. Because if you spend $46 at the concession stand, unless you're like at a concert, $46 at the concession stand, you just like bought like all the burgers they have. So we want to
Yeah. Some of them are good.
Right. So we want to move it all the way over there. And like 46 cents is probably not enough, like unless you're getting like a sucker or something. So we have to go all the way back over here. So now we have to count. I'm going to kind of skip count a little bit because I have 3. You don't have to count the commas. 6, 9, and then it's 10, it looks like. So we're going to write this as 4.62. So our new number becomes like I said, like kind of like lunch money, concession stand money, times 10. And then however many times we move the decimal. Now think about big number, so it should be a positive exponent. So it's going to be a positive 10 for my power. So I had to move it 10 times back. Now we have a really, really tiny number. So this is like the size of something so small, really microscopic little value that probably can't even weigh. It's hard to tell how small it is. Where does the decimal need to go? Between the 8 and the 5. So like $8.50 would be better than 85 or 0.85.
Gotta spend that 85 cents on nothing.
Right. So 8.5 times 10. We always use that 10 because we're base 10. And is it 6? Negative 6, you said? 1, 2, 3, 4, 5, 6. So, and right, a negative 6 because this is a really small number. So being able to switch it back and forth, and like I said, I think you guys have probably done this before, but just kind of reviewing. What we're going to do now is we're going to add in some like math with these because that really goes closely with what we're currently doing. So we're going to multiply with scientific notation. So we're multiplying these two numbers together that are written in scientific notation. And we want to multiply them so that they become like a new scientific notation equation or expression. So we're going to look at like basically the A values first, kind of like their coefficients. So I'm going to call them coefficients still. We're going to multiply those. I don't think they're technically coefficients because they're not really a variable, but I think you know what I'm talking about. We're going to call them the A's. So I'm going to multiply those together. So 3.5 times 2, I get 7. 7.0 or just 7. And 7's a good number because that's concession stand money. That's okay. It's not like a crazy amount. Now we're going to multiply the 10 part. Now, if they have the same base, well, we're multiplying, but we're gonna add them, you're right, but
Oh,
like,
okay, I was
we're
gonna
still
say
putting them
that's
together.
okay.
So we have to multiply that part, but you have to remember that the rule is when they have the same base, we add their exponents. That's why she was questioning my work here. So technically, we're gonna add the exponents. So it's gonna be 10 to the n plus n. So you don't change that 10, you just add their exponents because the bases are the same. And it makes sense that the number would get even bigger. So we, rather than moving the decimal 4 places or 5 places, we move it a total of 9 places. And so this number is done because it's written in scientific notation. Now this next one's a little bit trickier, and I'll show you guys why in a second here. There's a couple of things about it. So again, we're going to multiply the coefficients. When I go to multiply those this time though, we're going to get 24.96, I believe.
That's not
Okay. Even think about it as lunch money. If you guys came home from school and you said, hey, I spent $24 at lunch today.
good. Yeah, look at that. That's
Oh, that's annoying. Do you know how to, do you know like the button to switch it? This little SDA does it. Solved.
Thank you.
Yeah, I'm here for you. Most calculators have like little goofy tricks like that. You just have to know where they are. So if you guys are spending $24 on lunch every day, would your parents freak out?
Yes.
Yeah, because even today I bought my lunch at Quick Trip because I'm not going to lunch today because I have a meeting at lunch.
Good food.
But at Quick Trip, like I bought like a salad and like a yogurt, and like it added up to like $9. Like I mean, like I was kind of like, holy cow! Like if I bought my lunch every day, it would be really expensive, and like not like school lunch.
My parents would throw me in the highway.
Yeah, like no, yeah, like $24 for lunch every day would definitely be questionable.
Wait. You're saying you bought your lunch from Quick Trip and chose a salad.
Well,
Oh,
yeah.
you could have gotten the burgers. Those things are delicious.
But then it's gonna be cold by lunchtime.
Then you're reheating in the microwave. You got one right there.
I try to eat a little healthy because I do. But I know tonight I have to eat out because I'm taking Griffin to a game and walk. So there's a method to my madness. I have to.
It's a mom.
Yeah. Yeah. All right. So 24.96. Yeah, we'll talk about that in a second. Times 10 to what power? What does my exponent become? Becomes a 3 because it's 5 minus 2, so it's a 3. But the issue is this is not written in scientific notation because it's too big of a number. That's not okay for it to be such a large number. So we need to make that number smaller because, like, again, your mom would freak out if you were spending that on lunch every day. So we need to make this number smaller. If we make that number smaller to balance it out, we're going to make this one bigger. So it's like you basically are giving a decimal place back over to the exponent. So I'm going to make this one smaller, make it 2.49, which is probably actually closer to our actually lunch fee. And you can put the 6 on there as well. So just move it over one decimal place, $2.49, much more reasonable. Times 10, this is going to go up 1 because this one went down 1. So it's kind of we have to take into account that other decimal place. Okay? So some of these, if they're not in scientific notation when we're done, we have to like alter that. Okay? So once you guys flip the page, we're going to divide here in a second. And dividing is basically like multiplication, similar rules. You guys flip that over, and we are going to have homework. I just wanted to write it down correctly because of that other assignment, and so I didn't have it printed on here, so I'll fix that. So now dividing with scientific notation, similar to multiplying, where let's actually do this one first. This one's a little bit easier. I'm going to divide those two. Now this time 5 over 2, you might say, well, that doesn't simplify. We're okay with decimals with scientific notation. So 5 divided by 2 is going to be 2.5. And now Kylie knows how to put that into her calculator. 5 divided by 2? Okay, so we get 2.5 for that. So we're going to divide the coefficients, or the a values. So we get 2.5. Then we have to do what with the exponents this time? What's that? Remember, dividing, we're going to multiply and we added them, so dividing, we're going to subtract the exponents. Now, sometimes they're negative, so it gets a little weird. So let me show you guys. Now, in this case, we're okay with negative exponents because it just means it's a really small number. So you can do a couple of things here. You can do -3 minus a -7. That's okay to do. If that's too confusing, because that's a little bit of a mess, what can we do with these to make them positive? You can flip them. So just flip the 10 part. So if I do 10 to the 7th over 10 to the 3rd, what's that going to be? 10 to the 4th. It's a little bit easier to do if you're working with positives. So it's up to you guys. This is the same thing. You'll get a +4. So that's going to be our new decimal, or our new scientific notation. All right, just a couple more here. The video is going to be a little late today. I'm going to get through all these right now. All right, 1.3 divided by 5. That's going to be 0.26. Is that enough to buy lunch? No, we're going to talk about that then.
Oh, yes, most definitely.
Yeah. In 1962, it was enough to buy lunch. I don't know. So, all right. Ask Joan. She just said it.
I mean, Jonesy could probably tell you though.
Well, he can. He was only, shoot, he was probably 16.
All right, so 4 minus a -1 becomes 4 plus 1. Or you could move this one up. So this is going to be 10 to the 5th, right? So we're not quite done though, because we have that issue. 26 cents, not enough for lunch. So tell your parents that's definitely not enough for lunch. Don't let them just send you the quarter. There you go, buy your lunch. All right, so this one what needs to happen to that number to make it lunch money? It needs to get bigger. If this gets bigger, what happens to this? It's going to get smaller. We have to account for that decimal point somewhere. So that's going to become 2.6, which again is pretty good. It's school lunch, not like quick trip lunch.
Quick trip lunch is good though.
I know, but you don't get enough, or that you don't have enough money for that. You'd be spending too much every day. This has to go down one then.
It's literally
I
like
know people
$1 short for a burger. Not a salad, a burger.
How do you feel about my salad?
I feel like it was a bad choice. It's so much better food.
What kind of salad was it?
It's the chicken, bacon, cheese. Chicken, bacon, and cheese. Okay.
That one's not bad,
No.
but the Angus sourdough burger is way better.
Okay, so this last one here is just a number that's not in scientific notation. It's really similar to the other ones. I just wanted to mention it though because of this negative exponent. I just want to make sure you guys remember the negative numbers and kind of how they work. So obviously 25 cents, not enough. We're going to move it over and make it bigger. So this gets bigger. This one has to get smaller. Now, how do I make a -5 smaller?
Yeah, make it even bigger, negative.
Yeah, so it's going to become -6. So that's confusing. But remember your number line. Think of it as like colder weather. So -5, it's going to get colder and be a -6. All right, so I will explain homework in a little bit. We're going to take a break right now.
On Kahoot or walk?
Fun Kahoot or walk? What do you guys want to do?
I go fun.
I think I'm hearing more walks.